Okay. Hello, everybody. We are the Dundies. We are doing a fish reroute and integrated passage to transport migratory salmon around the Oxbow Dam.
A rising issue that has had an immense impact on the salmon population in the Columbia River Basin is the presence of dams. Dams are a necessity for humans to use in order to store water and generate clean power. They, however, present an obstacle for spawning salmon and a danger for young salmon. We, the Dundies, plan to develop and implement a successful passageway on the Oxbow Dam along the Columbia River Basin. Now, Jake is going to talk about the solution process.
So how did we get to the bypass riverbed design? We started out by trying a more mechanical approach to solve the problem. We created prototypes for multiple machines that could somehow carry the fish from the bottom of the dam up to the top of it. We soon figured out that the mechanical solution wouldn't be the most effective type of solution. With a lot of moving parts, it gives a high risk of breaking down. Because of this, we moved on to a more reroute solution, where there are very few mechanical parts. In designing this reroute, we decided to create a bypass river bed that allows a new passageway for fish to be able to swim from below the dam up to the top of it. Titus and Tiki will now go on to talk more about the solution.
All right, so for our design, I'm going to be talking about the reroute subsystem. So as you can see, as Jake said before in the past slide, that we went through a curvature design for the riverbed, and which the bottom is covered with pebble rocks to give the fish a natural feel of a river. And to go more into the curvature shape, we chose this design because it helps slow the velocity of the water as it travels down the riverbed. And we're going to add boulders as well throughout the riverbed to break up the current and give rest spots for fish as they make their migration to the spawning ground.
And in order to control the amount of water going through the riverbed, we designed a gate subsystem that would be able to adjust for varying reservoir levels. And the way we designed it is essentially there is a fill tank that will raise and lower a floating drum that will allow variable amounts of water through by also not making a huge jump for the fish to have to get over. It'll be small for when they're going up, and then it'll allow low amounts of flow for when they're going down.
And with all of that considering, the value of our design is very high. The cost includes multiple fixed costs like construction teams and equipment, which are the biggest. And some equipment includes solar panels, batteries, computers, and other smaller things. And the project requires a lot of variable costs and materials. There are lots of industrial materials ranging from concrete and different types of metals. And the estimated cost was about $300,000, which therefore becomes a large benefit to this design because the price of it is less than previously constructed fishways on the Columbia River Basin. And the design was also made where maintenance can occur during the off season. And there's also not very much maintenance. And the bypass also maintains familiar surroundings for the fish more than a ladder would, which is ultimately the best for fish. And changes can be easily made by increasing or decreasing the gate opening to work with runoff or weather changes. And that also means that it'll only be open during the migration season. So it's easy to make changes without hindering the ability of fish to move. And we will also be collecting data from an electrode sensor, which will provide stakeholders with valuable data about stability of salmon populations. And that is why it's so great. Yay.